All right, I'm Dr. Josh Bondi. I'm the Director of Research and a co-founder of the Nevada Science Center. I'm up here at the Mount Charleston Lodge with my partner in crime and also co-founder, Director of Education, Becky Hall. And so we are going to be talking about the Spring Mountains here in Southern Nevada. Anything else you want to say, Ralph, before I get going?
No, you go right ahead, Josh.
Go right ahead, all right.
If anyone has any questions, go ahead and message them in the chat, but go ahead and begin, Josh.
Sounds good. Okay, so the Spring Mountains are a prominent mountain range here in Southern Nevada. For anybody who's ever visited Las Vegas or Southern Nevada, it's the big prominent mountain range off to the west side of the Las Vegas Valley. One of the interesting aspects of being up here at Mount Charleston, we're a little bit over 7,000 feet where we're recording today. The peak of Mount Charleston, the highest point in the Spring Mountains, is just a smidge under 12,000 feet. Mount Charleston proper is the 8th highest point in the entire state of Nevada. Looking off behind me, all of these beautiful peaks behind me are all limestones. All of these limestones are marine rocks. And so we'll talk a little bit about how marine rocks got up to 12,000 feet above the Las Vegas Valley. We'll also be talking about some of the biology up here. And so why we have different types of trees up here up at Mount Charleston versus if you're down in the Las Vegas Valley, you have, if you're the higher parts, Joshua trees, and the lower parts, you have just kind of landscaping trees. So we'll talk about why we have different trees up here versus down in the valley bottoms. Believe it or not, there's almost 10,000 feet elevation difference between the Las Vegas Valley bottom and up here at the very top of Mount Charleston. So we're going to be talking about, again, the geology, kind of the history, again, all from up here at the beautiful Mount Charleston Lodge. So let's jump right into it. So just to give you a sense for where we're at, for those of you who aren't from Southern Nevada, I grew up in Fallon. I didn't know where Mount Charleston was growing up. So just because you're a Nevadan doesn't mean you necessarily know where everything in Nevada is, even though you should, especially if you're in geography class right now. So just a map of Nevada. So my hometown, Fallon, up here in the Carson Valley, or Carson Sink area. So we are down here just west of Las Vegas, at Mount Charleston, up here in the Spring Mountains, just to give you a sense for where we are at geographically within the state. So just so everyone's on the same page. All right, so and then geologically, I just mentioned at the outset, behind me, all of these rocks that make up the cliffs around us are all marine limestones. So ancient reefs that date between 500 and 300 million years old. If you go up in the mountains behind us, we are on federal land, so it's okay to collect invertebrate fossils, and I have some to show you. So if you were to go hike around the mountains behind us, I'll put a little dab of water on here because it helps with the contrast with the dark colored limestones. You can make out these corals and bryozoans within these rocks. And so these are ancient reef animals. So these are types of corals. Bryozoans are still around today as well, except they're called sea fans today. So when Nevada, about 500 million to 300 million years ago, was a shallow tropical sea. It's at the equator. And so animals like this could grow. And so dark colors in the rock, organic. So life was really prolific during this period of time, leaving lots of carbon behind, along with the skeletons, and they're long extinct. Interesting things about limestone, it's a calcium carbonate. That's what makes it up. You can kind of see here calcite crystals. So that's the mineral that makes up the shells of these little animals and also makes up the rock around it, except in microscopic scale. All right, so we're going to conduct an experiment. So all you teachers out there know, experiments work in the wild. So we'll see how this goes. This is just vinegar. Let's see. It works really quick, but it seems to go away just as quick as it starts. But when you put vinegar on these rocks, or you put really weak sulfuric acid or hydrochloric acid, or we call it muriatic acid when they use it in swimming pools, it'll start to fizz. And so that's a trait of limestone, a trait of calcium carbonate is that it fizzes when you put acid on it. And vinegar or lemon juice is an acid. So it fizzed really quick. You probably didn't even see it on the screen, but that's one of the aspects of these types of rocks. All right, now I smell like vinegar. So up here at about 7,000 feet, all the way to the peak of Mount Charleston, again, 500 to 300 million year old marine reef rocks. If you're standing in Las Vegas and you're looking west, you will see a big band of kind of yellowish to orangish rocks in the Red Rock Canyon area. Now, those rocks are different. Those are not limestones, and they're not 500 million years old. They're not 300 million years old. They're 200 million years old. And they represent the fossilized sand dunes of an ancient sand sea which spanned all the way from southern California to southern Montana. And so kind of southern Nevada over into Utah. So if you've ever been to Zion National Park, if you've ever been to Valley of Fire State Park, or if you've ever been to Red Rock Canyon just outside of Las Vegas, you'll see the brilliant sandstones out there, like this sample here. And again, these are fossilized sandstones or fossilized sand dunes. And you can kind of see the wind-blown sand within this rock. We do find dinosaur tracks in them. We find crocodile tracks, mammal-like reptile tracks. So there was life amongst these dunes. But again, these are 200 million years old. And if you look up the mountains, the ancient limestones actually sit on top of the 200 million year old sandstones. So how the heck did that happen? So what happened was 100 million years ago, when we have dinosaurs running around Nevada, and we do have fossils of these dinosaurs, raptors and sauropods and armored dinosaurs and iguanodons and duck-billed dinosaurs, all running around southern Nevada, there was a great big thrust fault. A thrust fault is a type of fault which shoves old rocks up and over young rocks. And so kind of what's going on is we have 300 million year old limestones being pushed up and over 200 million year old sandstones. And so when you look at the spring mountains from Las Vegas, you'll see the yellows and then you'll see the grays. And so what you're seeing is that relationship of these really ancient reefs having been shoved over the top of these ancient sand dunes, all when dinosaurs were running around. So kind of a complicated story, but not an uncommon story for Western geology in the United States. All right, so how did Mount Charleston and the Spring Mountains come to be in their modern incarnation? About 25 million years ago, with the San Andreas Fault over in California, beginning to stretch across California, beginning to stretch apart the Great Basin where we live here in the great state of Nevada, we began to get big normal faults breaking, which forced the valley bottoms like Las Vegas over here to drop down and uplift these mountains off to the west. And so all the mountains in Nevada run kind of north-south as a result of this basin and range extension. So Nevada stretches out at about 2 inches per year to this day as a result of basin and range extension. So the Spring Mountains are still uplifting, and all these mountain ranges across the most mountainous state in the country are also uplifting. So when we just had that big earthquake outside of Tonopah this past year, that we should expect those types of things here in a really earthquake-prone, tectonically active state. Okay. There's another artifact of living in a tectonically active state. So most of Nevada is in a rain shadow desert. So most of the moist air masses coming off of the Pacific Ocean get blocked by the Sierra Nevadas and other mountain ranges. But here up in the Spring Mountains, again, at the very highest peaks, we're about 10,000 feet above the Las Vegas Valley. So even though we're at the same latitude, we're the same direction north from the equator as Las Vegas Valley, we got completely different trees. If anybody is here living in Las Vegas or has ever visited Las Vegas, there's not really that many pine trees in the Las Vegas Valley. You don't really see the fall colors. I don't know if you can see the fall colors in the background behind me, but all right. All right, we're going to get a scan. We're going to get a panorama so you can see them, so everyone can enjoy the fall colors. So the quaking aspens are up here already turning colors. So we could see fall is in the air up here, up at 7,000 feet and above. But we also don't get quaking aspens in the Las Vegas Valley either. And so this idea of getting different organisms, different plants, different animals, as you go up in elevation is called the life zone concept. And the Las Vegas Valley up to Mount Charleston is actually one of the original areas where this concept was first derived. So the idea is, as we go up in elevation, we get a decrease in temperature. So anybody that lives in Las Vegas knows in the middle of summer, you go up to Mount Charleston to cool off. Because we're going up in elevation, we also get increased chances of intercepting those moist air masses. So more thunderstorms, more snowstorms. So it's wetter, it's cooler, even though we're at the same latitude north as the Las Vegas Valley. So I've got a couple of classic diagrams which show this phenomenon, and hopefully you can see this phenomenon behind me with the different plants and animals that are probably flitting back and forth in the background. All right, so here we have a diagram that shows my end screen. All right, so kind of going from out at Lake Mead, where we're in what's called the lower Sonoran life zone. So that's where you'd expect to see your creosote bushes and your spiny sage, spiny burr sage. Going up in elevation to the upper Sonoran life zone, where you're getting things like creosote still, but you might be getting also Joshua trees. And as you continue up in elevation, up as you're driving up to Mount Charleston, when you get to about the 5,000 foot elevation, you start seeing pinyon pines, junipers, sagebrush, kind of like the plants you'd expect to see if you live around Reno or if you live around Elko. As you go even higher up into the yellow pine forest, where we're about right now at about 7,000 feet, we get up into the ponderosa pines and Jeffrey pines. And so these are the big trees that we see in the background. These are our ponderosas. And then as we go even higher in elevation, if you were to take some of the trails up to Griffith Peak or Mummy Mountain or up to Mount Charleston proper, you pass into the fir forest, which is the Canadian zone, because you'd expect to see similar plants as you would see in Canada, up into the bristlecones, which is one of our state trees, and then eventually up into the alpine tundra. I don't know if we can pan over here and we can actually see where we get above the tree line up at Mount Charleston proper. So we kind of follow up our life zones as we go up in elevation, and as we pan over here to the right, we can get up above the tree line where it's so cold and there's so little precipitation up there, the trees actually can't establish themselves. Oh, and then during wintertime, these elevations also have the highest snow accumulations. So that leads also to them not being able to establish really good plants. So just another diagram showing more of the same. So if you're down near Lake Mead, salt brushes, Las Vegas, creosote bushes, as you started up the alluvial fans, Joshua trees, and then pinyons at about 5,000 feet, pines and firs about 7,000 feet, and then eventually we get up into the bristlecones at the highest elevations, the oldest organisms on the planet. All right. So if you go to any of the mountain ranges across the Great Basin, you're going to see a similar story. So if you are in Elko, if you're in Eureka, if you're in Fallon, if you find yourself in Lincoln County, Nye County, if you go up into any of the north-south running mountain ranges and you go hiking up into the mountains, someplace where it's safe, somewhere with your family, and you're hiking around, you're going to find marine fossils in all of those gray rocks. You're going to find corals, you're going to find sea fans, sea lilies, you're going to find things like clams and snails and clam-like relatives. So keep an eye out that when you're out and about, and you'll be able to find these marine fossils. And again, that's from a period of time 500 to 300 million years ago, when Nevada was a shallow tropical seaway. So for much of Nevada's history, even though today we're a big desert, this actually probably would have been a pretty cool place to go scuba diving if it weren't for all the terrifying creatures that also would have been swimming in the shallow tropical seaways with you. Some of these clam-like relatives, this is a brachiopod. So this is they're called sea lanterns today. They used to be much more diverse than they are today, but you can see kind of the lines of the shells. They kind of look like clams. They filled the same ecological niche as clams, but they take a big hit evolutionarily, ecologically, about 250 million years ago. And that's when clams and snails take over for the job they used to do. Some other interesting fossils. Here we have some corals. So this is the outline of a coral here. Another coral here. They're a little bit squished because of, if you think of all these big masses of rock smashing into one another tectonically through time, fossils often become tectonic roadkill, we call it. And so we can see them kind of get smashed and smeared and deformed by faults and all the things that, all the processes that beat up rocks through time also beat up fossils. Let's see. I'm trying to, we were hoping that some animals would come visit us in the background, but we went on a hike just yesterday, or this weekend, and some other animals that you would expect to find in the Las Vegas Valley. We oftentimes through the valley get lots of jackrabbits, cottontails, roadrunners, sage sparrows, animals like that. But as you come up here at about 7,000 feet elevation, the life zone concept just doesn't just hold true to plants, it also works for animals as well. And so just on our hike the other day, we saw a whole herd of mule deer. And so mule deer, which are common across northern Nevada and the mountains of southern Nevada, are not all that common down in the valley bottoms. If you're at the valley bottoms of Las Vegas, you'd expect to see things like desert bighorn sheep, not necessarily things like mule deer. Other animals that we observed up here were things like burros, so donkeys. Donkeys are not native animals, but they enjoy southern Nevada because where donkeys evolved, where they originally come from, are desert environments of North Africa. And so they're right at home here in southern Nevada where it's also a desert. So they're adapted to that type of climate. Just a note of caution, if you do see burros or wild horses, please don't feed them. They're wild animals or wild feral animals, and they're not necessarily safe, cute, cuddly animals. So just protect yourself, protect your family. Don't ever feed animals when you're out on hikes or when you see them out in the wild. Other animals that we've seen out here, so rather than road runners, we see animals up here like Steller's jays, mountain bluebirds, which are our state bird. We also see mountain chickadees. And so these are all animals that don't live in the valley bottom of Las Vegas, but live up here in the Spring Mountains. Let me go back to my diagram. To explain things via pictures. So here we have same animals that live up here near Lake Tahoe. So again, Steller's jays, mountain chickadees, animals like that. But this is a really, so how did these mountain animals get down here if they also live up here and there's nothing but desert in between? Well, during the last ice age, it was continuous forest across the state of Nevada. And up here in northern Nevada, we had a couple great big lakes that existed during this period of time, maybe a topic for a story later down the road. So as climate dried out, as we came out of the ice ages to our current climate, and the valley bottoms became deserts, and the pine trees went up the mountain sides. These are what we call now sky islands. And so these sky islands, they act just like islands in the middle of the ocean, except they're isolated by deserts. So we get these island ecosystems out in the middle of nowhere. So just some interesting geology, some interesting biology, and a story which is truly Nevadan from here in the Great Basin. So with that, I'm happy to entertain any questions you might have.
Thank you so much, Josh. And again, if anyone has any questions, go ahead and message them in the chat. So our first question, student wants to know, do mushrooms grow in that area?
Yeah, so fungi are actually one of the most successful groups of organisms in the history of life. And so if you go to wherever there's enough moisture, wherever there's decomposing biomass, you'll find fungi. And just in our hikes up here, I'll be the first to admit I am not a fungus expert, so I can't tell you what species they are, but there are mushrooms up here. There's toadstools up here. They grow on the tree trunks. They grow in the understory. They grow in some of the more wet waterways. Just a word of caution, though. Many mushroom species are actually highly toxic to humans. So even if you see them, please, please, please do not try to eat them.
We will take your word for that. Thank you. Another student wants to know, does it snow a lot up there throughout the year?
Not necessarily throughout the year, although I have seen the random snowstorm in June or July. Those are the exceptions with their elevation, which we did not get this past year. Snow up here up until early. There is actually here, and so we get enough snow up here that you can.
So, Josh, can you hear us? You were cutting in and out. Josh?
Oh,
No,
I
we
just
can
cut
hear
you
you
off?
now. Can you hear me now, Josh?
Okay. Yeah, I've got you.
Okay, good. So we had,
Can you hear me okay?
yeah, I
Okay.
can hear you. So we have some students want to know if there are any snakes and bears up in that
Okay.
area. Josh, did you get that question?
So there are no bears in the spring range. Yeah, I got it. So there are no bears. Can you hear me okay?
Yeah, you're good. You're good.
Can you hear me? Okay. So there's no bears in this mountain range. Black bears haven't been here since the Ice Age. Grizzly bears used to be here during the Ice Age as well. As things dried out, they've gone away. So there are no bears in this mountain range. There are, however, snakes. And so there are venomous and non-venomous snakes. So it's one of those just rules of thumb when you're hiking in the mountain. You can't see. Your ear battle if you hear with you. So they'll let you know. Are you still there, Ralph?
So I'm guessing you were talking about the rattles. You were cutting in and out there, Josh. But what Josh was saying, if you hear or see any snakes, stay away from them. So we will wrap it up with, we'll try and get another question. Were there any crocodiles ever there in this part of Nevada? Someone asked.
There have not been crocodiles in this part of Nevada for 100 million years. We do find them in Valley of Fire from rocks about 100 million years old.
Okay, so it sounds like an elevation kind of thing. That's interesting. Someone wants to know, what's the oldest fossil that you've found in that area of Nevada?
So the oldest fossils that we've found in this part of the state are trilobite fossils. And so trilobites are just kind of the relatives of insects and crabs and arthropods. They are a type of extinct arthropod, as a matter of fact. And those are about 500 million years old. So 500 million years old.
And someone wanted a follow-up question. Were all of the oceans connected at that point in history?
When Nevada was a shallow tropical sea, that, for some of you may be familiar with the term Pangea, that was the most recent of supercontinents when all of the continents of the world were one. So yeah, all the global oceans were connected.
Someone is asking, what would be the easiest hike in that area if students wanted to see fossils or rock samples?
The easiest hike up here, if students wanted to see fossils or rock samples, you could just come up here to the Mount Charleston Lodge and hike around the hills behind the lodge. Be safe around the roads, though. There's also the Mary Jane Falls trailhead, which is not too far from here. You don't need to go all the way up to the falls, even though it's a beautiful hike, but it might be a little bit more technical for the younger hikers. But anywhere in the hills around here, you can find fossils and you can find limestone samples and things like that. These are your public land, so you should enjoy them.
That's good advice. So before we let you go, is there any advice you could give to students who are interested in studying geology?
Any students who are interested in studying geology, get out there and look at their rocks. You're going to learn it best by seeing rocks in the wild, in their natural habitat. Read as much as you can. If you're interested, you can send an email to info@nvscicenter.org, and we'll be happy to send you reading lists, send you materials. And if you have a budding geologist at home, we're happy to fan that flame.